Hi, welcome to another Algebra 1 video. In this video we're looking at section 3.4, which is graphing linear equations in standard form. In this video we will learn about graphing linear equations in horizontal and vertical form, and we will also learn how to graph linear equations in standard form using x and y intercepts. So let's talk about horizontal and vertical lines. We know that the most common format of writing linear functions is with the equation y equals to mx plus b, where we know that the letters m and b are constants and the letters x and y are our variables. So far we have learned that we can graph many types of lines. You could have a line that looks something like this, a line that's more steep, which may look like this. You can also have a line that's pointing in the opposite direction, or it has a less steep slope in the opposite direction. But we haven't learned from the equations what horizontal and vertical lines look like. We know that we can represent these lines with different linear equations. So for these lines we have a coefficient of 1 next to the x, which determines the slope or the steepness factor of the line. And here we have 2, so the line is steeper. And here we have -2, so the direction of the slope is reversed. And in this case our m is -1. And for most of these equations we have a constant value that is being added. So here we're adding 1 to the rest of the equation. And here you could say you're adding 0, which is the same thing as y equals to 2x. And you're adding 0 over here as well, which is also the same thing as -2x. And here we're adding +1. But what about horizontal and vertical lines? What equations represent these two lines? Let's look at the horizontal line. When you're writing the equation for a horizontal line, we get y equals to mx plus b. However, the m value is 0 in this case. So we get y equals to 0x plus b. And we know that anything multiplied by 0 is simply 0. So y equals to b. For example, if you take the equation y equals to -2, then we can rewrite this equation as y equals to 0x minus 2, which is the same as this step. And let's graph it using this equation. So we can plug in some values for x, like 1. You could plug in y equals to 0 times 2 minus 2. Or you could plug in y equals to 0 times -1, and so on. You could pick whatever number you want. You will always end up with this number in the end. So all of these equal to -2, y equals to 0 times 2 minus 2 will equal to -2, and y equals to 0 times -1 minus 2 will equal to -2. This is because all of these values, the mx values, equal to 0, so the net amount for your y is -2. So this tells you for the values of x equaling 1, you will get -2 for your y value. For your x equaling to 2, you will get -2, which is the same as the previous point. And for the third point, -1, you will still get -2. So for whatever x value you plot on a coordinate plane, if you plug in 1, -2, you place the point here. If you plug in 2, -2, you place the point here. And if you plug in -1, -2, you place the point over here. And we can connect the dots, and you can see that you get a horizontal line. So all of these points have the same y value of -2, which is the equation that we had. And our x could be all real numbers. Whatever you plug in for x, you will always get y equals to -2, and therefore your line will be a horizontal line. But what about vertical lines? In horizontal lines, we learned that for every x value, we have a constant y value, which is along this line. So if this line was y equals to 2, then all the y values of the coordinates would be 2, and x would be all real numbers along the number line. So we could have 0, 2, you could have 1, 2, 2, 2, and so on. But when you're talking about vertical lines, it's the opposite. We know that the dependent variable is the y, so when you're talking about the opposite, it must be x. So a vertical line in this case could be x equals to 2. And in this case, we know that all our points lie along a vertical line, and our x values are only restricted to one area, which is 2. So the points in this case could be 2, 0, which you could call this one. You could say 2, 1, 2, 2, and so on. So in a vertical line, you have all the x values a constant of 2, while when you have a horizontal line, you have all the y values that are constant of 2, or whatever b value you pick. So let's look at some problems of horizontal and vertical lines. In question 1, we're given that x equals to -2. So we know that for the coordinates of x equals to -2, our x values will always be at -2. So we can start at -2, 0, and our line will be vertical, and all our points will lie at x equals to -2, and our y values will be all real numbers as they extend to positive infinity or negative infinity. So this point is at x equals to -2. In number 2, we're given that y equals to 100. So it's the opposite because we have the y variable, which is a dependent variable, In this case, our line is going to be horizontal, and we know that the x values will be whatever they want to be because x is not restricted, but the y value is restricted to 100. So for all the x values along that number line, you could have an x here, here, and so on. So this line will intersect the y-axis at 100. In number 3, we're given x equals to 20. So this time we know that our x value is restricted to 20, so we can put a point at 20 on the x-axis. But we know that our y values are not restricted, so we can have y values in the plus infinity direction or in the negative infinity direction. So we could have points here, 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 and in the negative direction. And you can connect the line and mark this point as x equals to 20. So in this case, our x value is restricted to 20, while the y values can go anywhere they want, to positive infinity or negative infinity. While in this case, our y value is restricted to 100, so you can't go any above 100 or any below 100. But our x values can be towards negative infinity or positive infinity. Now let's talk about graphing in standard form. We know that the most common form of graphing linear equations is in the form y equals to mx plus b. However, there's another form, which is the standard form, which is given in the form ax plus by equals to c, where a, b, and c are non-zero constants, and the x is the independent variable and the y is the dependent variable. When we graph lines that are not horizontal, it happens that the line intersects with the y-axis and it also intersects with the x-axis. So in this case, we have our y-intersection at this point and our x-intersection at this point. This value is known as the y-intercept, and this value is known as the x-intercept. In this equation, our y-intercept is at this point, as the line crosses the y-axis over here. And for the x-intercept, it's at this point, because the line crosses the x-axis at this point. Using the format ax plus by equals to c, you can graph a linear function using the x-intercept and the y-intercept. So let's say you have the equation 2x plus 3y equals to 9. In order to find the x-intercept, we have to turn this term into 0. And we can do that by plugging in 0 for y. So to find the x-intercept, we get 2x plus 3 times 0 equals to 9. We know that 3 times 0 is 0 because anything multiplied by 0 is 0. So we get 2x equals to 9, and x would equal to 4.5 if you divide each side by 2. So the coordinate of the x-intercept would be 4.5, 0, because our point only lies along the x part of the coordinate and not on the y part of the coordinate. To find the y-intercept of the linear function, we turn the 2x, or the term including the x, ax into 0. And the only way we can do that is by plugging 0 for the x. So our function is 2x plus 3y equals to 9. To find the y-intercept, we have to plug in 0 for the x, plus 3y equals to 9. 2 times 0 is 0 because anything multiplied by 0 is 0. So we get 3y equals to 9, and we can divide each side by 3, which will give us y equals to 3. And since we plugged in 0 for the x, our x value for the y-intercept will always be 0, and our y value is 3, and our x-intercept would be 4.5, 0. So to summarize, to find the x-intercept, we have to plug in 0 for the y. To find the y-intercept, you have to plug in 0 for x, so x equals to 0 in the ax plus by equals to c function. So for the equation 2x plus 3y equals to 9, our y-intercept would equal 0, 3, and our x-intercept would equal 4.5, 0. Note that when we find the y-intercept, our x is always 0. That's because we plug in 0 to find the y-intercept. And when we find the x-intercept, our y value is always 0. That's because when you find the x-intercept, we let that y value equal to 0. So let's draw a fresh graph on this coordinate plane. And instead of using a table set, we're only going to use 2 points, which are the x-intercept and the y-intercept. So our y-intercept was 0, 3, which would be at this point, 0 along the x-axis and 3 along the y-axis. For the x-intercept, we got 4.5, 0. So we would drag 4.5 along the x-axis, and since our y value is 0, we let the y value stay here. And so if you connect the dots, you get a line that passes through 0, 3, which is our y-intercept, and it passes through the x-intercept, 4.5, 0. And this is it for section 3.4. I hope you found this video helpful and you understand how to graph using the standard form, and also the differences between horizontal and vertical line graphs. Leave a like if you found this video helpful and subscribe for more videos in the future. And I'll see you in the next video. Thanks for watching.